So, we had discussed the components of a nerve. We had looked at the spinal cord in general overview detail. You know that the regions or the levels are named for the vertebrae in the vertebral column. We talked about the idea of plexuses, which we'll look at in more depth today. And we looked at the spinal nerves. So you know that the anterior is motor, posterior is sensory. There's a one-way direction of flow through the spinal cord. Information comes in at the back and leaves at the front. Those roots are one way, but they combine immediately to make nerves that have bidirectional flow. So information's going in both directions. We're going to look at those nerves in a bit more detail and the plexuses, one plexus specifically today, and maybe we'll get into reflexes, we'll see. But this was what a nerve looked like. If you took a spinal nerve, cut a cross-section through it, you can see bundles of individual axons wrapped together, and we looked at the wrappings or the coverings. And some of this detail we'll return to. The prefix just means the level. Endo around the inside, epi around the outside, like endothelium or epithelium. And we'll see these coverings again when we talk about muscle. But I digress. So, spinal nerve, leaving the spinal column, has just combined. There is sensory and motor information. And what does it do? Immediately splits. It's just combined, and now it immediately splits. The spinal nerve, in its largest form, is very short-lived. And it splits into two branches that have special names. We call them rami. Rami, R-A-M-I. Right after passing through the hole between the vertebrae, the spinal nerve splits. One of the branches is the posterior ramus. Rami is plural, ramus is singular. And the posterior ramus is very small. And it's small because it has a very limited series of tasks or jobs. All it does is passes over part of the bone of the vertebrae or vertebra into the muscles of the spine. And it innervates the muscles of the spinal column. It receives information from those muscles, and that's all it does. So if you are thinking about it, you can feel your spinal column now, and there's meaty sections on the sides. You're not feeling these muscles, but immediately deep to the muscles that you're touching right now, the posterior rami deal only with those deep spinal muscles. Those are very few. There are a lot of other muscles and structures in the body. There are biceps and knee flexors and plantar flexors in the foot. There's glands. There are arteries and veins that receive nervous signals. All of the other structures in the body are innervated by the anterior rami. So the very small branch takes a quick left turn, innervates the deep back muscles. Every other structure gets information sent to it through the anterior rami. And every other structure returns sensory information through the anterior rami. And notice they're a bit bigger. They have more varied tasks. There's more structures that they're targeting. They need to convey many more neurons. So the anterior rami are the beginning of every peripheral nerve. When we talk about muscles shortly, not shortly, maybe next week, and we say this muscle is innervated by X nerve, it started as an anterior ramus. Or maybe it combined a couple different anterior rami, but every other muscle or structure in the body, on the peripheral, in the periphery, gets information from the anterior rami and returns sensory information back to the spinal cord accordingly. Okay, so anterior rami are leaving on a journey to go to the rest of the body. What happens next? Do they just go in a straight line? Is it linear? That would be too easy. Next, what happens is the anterior rami weave together for some reason. They weave together in what we call plexuses. And a plexus is just, it's a braided network. After leaving the spinal cord, the anterior rami will combine with other rami, which then split. It might combine with 2 or 3 rami and make a big cord, and then split. Importantly, whether they combine or divide, every combination and division takes with it both motor and sensory fibers. The nerves at this point are a two-way street. Most of them. Some are exclusively one or the other. Most of them are a two-way street. It's not like the roots of the spinal cord, which are only exclusively one way. Dave or amps. These ones are combined. Now the name of the plexuses and the name of the fibers we are going to get into today. You'll be overwhelmed by it, but don't feel bad. Maybe feel bad. It's not so important right now that you remember all of the names. I'm introducing them because we will come back to them. But typically, like with anything in the body, the name gives you a hint of what structure is its target, or what is it doing, or where is it in the body. The name is very descriptive. They're not arbitrary. It's not alpha 2, 3, phi, epsilon, y. They're very specific, and they give you information about where it's going, what it's doing in the body. It's not random. Now, there are 5 plexuses in total. They generally arise, forget it, we're studying one plexus only. There are 5, but we're going to look at one in depth. And it's the brachial plexus, which is the source of all the upper limb reflexes. All the muscles, structures, nerves in the upper limb get their signals from nerves that travel through the brachial plexus, or arise from the brachial plexus. And then information going back to the spinal cord or the brain, for instance, me touching my palm, is going through the brachial plexus. The brachial plexus is the gateway to the upper limb. This is also the one that you can easily damage when you dislocate your shoulder, which I've done 3 or 4 times, which is why I'm curious about it. So this looks like a mess. This is the brachial plexus in all its glory. Almost all the nerve supply to the shoulder, and certainly the upper limb, originates here. From only 5 spinal roots. And so all the way on the right-hand side, you can see the spinal roots arising. And remember, they're named for the vertebrae, the intervening vertebrae. The names of the nerves are given in this column, and I just put up these blocks to show you what the bones would be if we looked at the bones right now. But we're waiting for a little bit to talk about the bones. And so if we go from a high-level overview and drill down, what is the brachial plexus all about? First of all, notice the weaving together of nerves, right? Spinal roots combine, then they divide, then they combine again, and they give off individual nerves throughout the entire process. In very general terms, the spinal nerves are the most medial portion, right? The most proximal portion. The spinal nerves are what we just looked at. These are the anterior rami of the spinal nerves. These combine to form trunks, and the trunks are typically right in the neck. If you wanted to, you could probably push down hard enough and feel a twinge. The trunks of the brachial plexus are in the neck. The trunks then split off and recombine into divisions. The divisions happen at the level of the clavicle. The clavicle gives rise to cords, and there's very few modifications left. There's one obvious modification that I'll point out, and then in the axilla, or the armpit, under the clavicle, deep underneath the pectoral muscles in the armpit or the axilla, you find the nerves. And at this point, the nerves are on their way to do whatever it is they're doing. There's some combination and reassortment of the nerve fibers. But then at the level of the axilla, the armpit, everything is leaving to go down the upper extremity to do its job. So let's explore in excruciating detail the brachial plexus. The first thing that you will want to use to orientate yourself is these combinations, the combinations and divisions follow a very specific pattern. It won't look random. If you were ever to see a model, it would always look somewhat like this. And one of the defining features of the brachial plexus is this M shape. There's always an M. And the M is really important because there are three large nerves that arise from the tips of the M. And if you were to see this in the body in relation to other structures in the body, the M sits on top of a couple important arteries and veins. So not only are there nerves in this area, there's also blood flow and vasculature and other tissue as well. But the nerves, or the arteries and veins run right in the middle, which makes it even more confusing. But we're only looking at nerves right now. So the letter M is what you use as your landmark. And from top to bottom, MMU is your guide. The name of the nerves is always MMU. Musculocutaneous, median, ulnar. For right now, let's say memorizing those is best until we look at the distal structures that they innervate. Always musculocutaneous, median, ulnar. The last nerve that arises is not part of the M. It sits beneath the M, and it's the radial nerve. These are the four major nerves that we'll return to when we get to muscles in the upper limb. So knowing where they arise is pretty important. MMU is your at the bottom beneath it all, the radial nerve. What other detail can we add to the brachial plexus? Those are the branches, the terminal branches, the nerves, but there are some elements that arise from cords or trunks or even the spinal roots. And so we're going to move progressively more medial as we discuss these nerves. So the lateral cord gives rise to the lateral pectoral nerve. The medial cord gives rise to what is highlighted in the book as the medial cutaneous nerve, but I call it the medial antebrachial cutaneous nerve. This is of the forearm specifically, and remember the forearm is a loose term to describe the antebrachial region of the upper arm, whereas the arm is a loose term to describe the brachial region. So more specifically, in correct anatomical terminology, the arm is brachial, the forearm is antebrachial. So the medial cutaneous brachial or antebrachial nerve. Next is the medial brachial cutaneous nerve. Finally, medial pec nerve arises, which pierces one of the pectoral muscles in innervating it. All of those are on the medial cord. On the posterior cord, there are four obvious branches. Axillary nerve on top all alone. It's really easy to see. It's the only one in that region. Below it, there's lower and upper subscapular. And then sitting between them is thoracodorsal. But with that, we complete the cords. There's no more nerves arising from the cords. However, we can move to the trunks to see two more. On the superior trunk, suprascapular nerve sits. Behind it, nerve to subclavius exits. We're at the lowest point in the lecture right now. I fully am aware of that. We're going to bring it back, though. Don't worry. If you look towards the ventral rami, the anterior rami, dorsal scapular comes off of C5. Lastly, long thoracic formed from C5 to 7. And by now, you're probably in brachial plexus heaven. Because you can confidently name all 16 nerves of the brachial plexus. Are you ready to bring it back? How will you ever remember that information? Believe it or not, as I was listing those, I wasn't looking at notes. That's all from memory. And it's not just that I have an exceptional memory or that I've taught this a couple times. When I was in undergrad, I took anatomy in my second year, and then I went back as a TA for 3 years straight. And we had a cadaver dissection course in my university career, which was really impactful, really, really awesome. And as a TA, we would prepare the bodies. We would section them, we would cut them, we would get the structures of interest ready for that week, and then the students would come in with scalpels and poke and prod and everything else. And so it was a job for two people. You can't lift a person and put them through a bandsaw and then take them back to the table and do that on your own, which I did. And what's surprising is the teeth spark. You never really thought about that, but the teeth spark a lot. So anyways, it's a two-person job, and the other fellow that I worked with was an aspiring musician that made a fantastic mnemonic device, a song for the brachial plexus, which I'm going to share with you now, and which I'm going to post to Moodle, which will get stuck in your head for days, but which is incredibly useful in the droning monotony of listing all 16 nerves that I just showed you. And with this, we'll probably end for today. But if you're taking notes, good. If not, scramble and take notes now as you enjoy for the first time the brachial plexus song. It's catchy. If we say had a pop quiz right now, you could answer all of those. You could give up all the nerves, no problems, right? We're not gonna have a pop quiz, don't worry. When you review the video and you listen to the walkthrough, you might have even noticed earlier that some of the things that I said rhymed. I was just reciting the song. It just gets stuck in your head, and anytime that you need to, or even when you don't need to, it comes up on its own. So that'll be a useful tool, hopefully, to study for midterm 2 as you learn the brachial plexus. And I don't know what I was thinking. We have a lot of time left. We're not starting yet. I thought I saw 12:57, but it's 47. I was looking at the timer on the other side. It would have been a really strong point to end the lecture on, wouldn't it? Yeah? You know what the best news is? That's not the last song. I love that enthusiasm. That's good. So that was a fellow named Matt Brace, who is now a plastic surgeon. I think he moved to LA. He was in a punk rock group and did Warped Tour a couple times. Made that song. Really diversified interests. Pretty cool guy. So he did that one fully. The next one that you hear, you might even hear some familiar voices. But we'll see. Anyways, let's move on. Brachial plexus, you can figure it out. That didn't rhyme, which is why I didn't write the song. What we want to focus on now is a more general understanding of how the spinal cord works. So the brachial plexus is the culmination of nerves in the spinal cord arising to go to their destinations and do a job. They're returning information back to the spinal cord that needs to be processed. But how is it processed? Is it processed in the spinal cord? Is it processed elsewhere? Can we understand the coming and going of signals? And what does the spinal cord do specifically to help integrate that information? Its two main jobs, as a major conduit and the connection point between the central and peripheral nervous systems, is to convey information. So anything from the periphery that needs to go to the brain, the spinal cord will propagate or convey that information. Any information from the periphery that needs to go to the brain is typically important. Any information that's not important doesn't have to go to the brain. So, some of the information can be processed or integrated in the spinal cord. And what I'm describing to you are reflexes. And we'll talk about them in detail, but you've probably heard of what reflexes are. You know what to expect when you think reflexes, or some of you were in lab this week and you have firsthand experience. How does the information move within the spinal cord, and how is it integrated? We've seen these terms before. White and gray matter are responsible for those roles, respectively. White matter is the conduit. We'll see why it's called white matter and why it's a good conduit on Thursday. Gray matter processes the information. Gray matter is where the synapses occur. And wherever synapses occur, information is modified or interpreted or processed. Remember, synapse is just a connection between two nerves or two neurons. So the gray matter will receive the signal and integrate it. I often use integrating as an interchangeable term for processing. And so with these distinct roles, you're probably thinking back to the distinct structure of the spinal cord, and you're right to think of that distinct structure, but even within those two general umbrellas of white matter versus gray matter, we can break down function even further. There are tracts in the spinal cord that have specific jobs. Some of them are highlighted here in red and in blue. And like with the other highlighting so far, red is motor, blue is sensory. tracts. Remember, the tract is just the conduit. It's a series of nerves that move together from point A to point B, and information travels up and down along the tract. Some of the motor tracts are shown here. The spinal cord will convey all motor information between the central and peripheral nervous systems. But some important tracts are highlighted here. The corticospinal tracts. Corticospinal tracts. Cortical, the prefix, represents the cortex, so the highest order regions of thinking in the brain. Spinal, corticospinal, is a tract between the cortex along the spine. So these are for voluntary signals. The cortex is the stuff that you are aware of. And so voluntary signals to lift my arm just went down the corticospinal tract in my spinal cord. So these are somatic, they're voluntary, you are consciously aware of them. And these two specifically are what we call direct. They are direct tracts. And all I mean when I say direct is that these motor tracts go through the pyramids of the medulla. Remember the pyramids? That's where the motor tracts crossed over, and why your right brain will activate structures on the left side of your body. Direct somatic motor tracts go through the pyramids of the medulla. So a couple interesting ones that we put up there. There are others, as you can see, but I'm only looking at the corticospinal tracts. So these are somatic information to do something that you have voluntary control over. The complementary sensory information is always carried in the dorsal aspect, the posterior aspect of the spinal cord. The posterior column is all of the white matter between the dorsal horns. All of this white matter, even though it's not highlighted on the left side, it's mirrored on the left and right side. The posterior column transmits all of the somatic sensory information to the cortex. Every sense that you are aware of travels up this posterior column. So when I gave the example of touching my palm earlier, that signal goes through the brachial plexus, into the spinal cord, up the posterior tract in the spinal cord, and I'm aware now of the fact that I'm touching my hand. The sensation of me touching my hand arises to the cortex through the posterior column. Anything, heat, pain, proprioception, which was a fancy word for the position of your limbs in space. I can close my eyes and I know that my arm is raised. That's a proprioceptive sense. And so these tracts are really important in relaying information. Now let's focus on that relay. The relay of information. Clearly, signals need to be sent from one point to another, and then back again, constantly. There's a lot of traffic. Let's try to understand, in general, how signals might be sent within the body. This is a fairly complicated schematic, and you can follow it in the notes online. The numbers do a nice job of leading you through. But in general, I'm going to highlight 3 scenarios where sensory and motor signals would travel in the spinal cord. There's 3 scenarios. Scenario 1, information is only sensed. So some receptor sends information to the spinal cord and it's relayed to the brain. There's either a receptor in the skin or a muscle or somewhere in the periphery That receptor is activated. This is very similar to the structure of a feedback loop that we talked about at length. That receptor is activated, and that signal goes right up the ascending sensory tracts to the brain. So I'm aware of that sense. I don't have to do anything about it, but I'm aware of it. The other two options warrant a reaction. The other two options need something to happen. They need a response. The other two options are reflexes. I'll just put them all up there. The other two options are reflexes. Let's look at the top one, the first one, motor number one. This is something that needs a response from the brain itself. So there could be a signal in the periphery, maybe a pain sensation or a heat sensation, something that represents imminent danger, something that needs you to think about it and do something. That information is relayed to the spinal cord, where it synapses with another neuron that sends it to the brain. And the brain then does something about it. It creates a plan of action, and sends that information back down this red line, the motor descending tract, to move out of the way. Did you just sit down on a thumbtack? You don't want to stay there, you want to get up. And so you activate the muscles that allow you to get up and move around. The second motor example, the third type of conveyance, is very similar, but it is faster. It's very similar to what we just described, but it cuts out the middle person. It doesn't need the brain. This is intense, severe activation of a sensory receptor that I need to react to immediately, and it takes too long to send the information to the brain and wait for a response. So I'm just going to send it to the spinal cord and then react accordingly. This motor number two sends a signal to the spinal cord where it is processed, that is, it synapses with a motor nerve directly. So I don't have to wait for the brain to turn on a motor nerve. Instead, the signal goes into the spinal cord, relays with a motor nerve, and then the muscle's activated. Often if you sat on a thumbtack, you wouldn't have to sit and think about it. Okay, I'm on a thumbtack. What should I do about it? I should probably stand up. Okay, I'll stand up. You don't have to do that. You jump out of your seat. That's the kind of response that's typical of a motor 2 relay. All of these are forms of reflexes. So let's introduce the concept of reflexes, and then we'll end for today. I'm not kidding this time. So reflexes and reflex arcs. A reflex is a fast, generally involuntary response to a stimulus. It could be to stand up after sitting on a thumbtack. It could be to open up some blood vessels to allow blood flow to return. It could be to accelerate or slow down heart rate. It could be to increase or decrease metabolism, to maybe warm yourself if core temperature is getting too low. These are all reflexes that help to maintain homeostasis, that ideal working range. In most cases, these reflexes will be processed directly by the spinal cord. The gray matter in the spinal cord will do the processing. If the motor nerve arises from the spinal cord, the loop that we are describing is called a spinal reflex. If the loop includes the brain, it's called a cranial reflex. Pretty simple and straightforward. Both are quick involuntary responses to a particular stimulus. Now, of those two types, spinal and cranial, you can have reflexes that you are aware of or not. You might have a somatic reflex that you are aware of, where you need to activate skeletal muscle. Remember, somatic is the voluntary branch of the nervous system. The somatic reflexes are things that you are aware are happening. Jumping off the seat in response to sitting on a thumbtack. The autonomic reflexes are things that you are not aware of happening. You're not aware of your arteries dilating. Maybe in extreme special cases you might be, in which case we should study you, but for the most part, you're not aware of that. You're not aware of body temperature fluctuations up and down. Those autonomic reflexes follow the same spinal or cranial pathways, but you're not aware of them. And so the reflex describes the actions, the reflex arc describes the circuitry, the nerves and the pathway that the signals travel through in completing the reflex. So we will come back to class on Thursday and explore examples of these different kinds of reflexes. Have a wonderful day. Watch for your marks in case they get posted early. Otherwise, I'll have an update for you on Thursday in class.